Today, we will talk about Venn diagrams. Now, the main idea here is that we will use Venn diagrams to separate and compare data between groups. This is one way to visually understand scenarios where data is involved. Maybe you have seen Venn diagrams before, and maybe today is just a small refreshment as to what a Venn diagram is. So let's get started. Now, here's some Venn diagrams. Venn diagrams are always going to look this way. They're always in a circular manner, and sometimes they will intersect and sometimes they will not, but they're always represented as a circle most of the time. But now, these circles have no meaning if we do not understand the scenario. So the first thing that you want to do is understand what those circles represent. So let's read. So here, the scenario that we have is that at a high school, some students are going to take Spanish and some do not. Also, some students might take art and some do not. Now, here we know that S is the set of students who take Spanish, and here we know that A is the set of students who take an art class. Now it says on the following Venn diagram, we will shade the region that represents the following scenarios. So now we know what this diagram represents. Here, this circle represents all the students who will take Spanish for S, and this is the circle for those students who will take A for art. So this is what we have. Now let's understand the first scenario here. All we're going to do is just going to shade the correct region. So here, our first scenario is we want to know those students who take Spanish class. So what do we know here? We know that S stands for Spanish, and this circle are those students who take Spanish class. Let's just make a better job here with the circles. So this is a circle that talks about those students who take Spanish. Right now, at least in scenario A, we're just concerned with those who take Spanish. So that means that we're going to be circling and we're going to be shading the region for those students who just take Spanish. So we're just going to circle and shade the circle that talks about Spanish. This is it. This is pretty much it. Now, let's look at example B, or the second scenario. Here we want to just shade the region for those students who take an art class. So it's going to be the same idea, but we're not going to be circling those students who just take Spanish. Right now, our task is those who are taking an art class. So that's pretty much saying just circle the circle that talks about A, because we know that A stands for art. So this is the circle for A, and this is the circle for S. It gets a little more complicated. Now let's look at example C. Now, notice here that we want, in example C, we want those students who take Spanish and also takes an art subject. So we want to know the region that those two circles have in common, because whenever they use the word and, you can think about it as the intersection. Section. Oops, blanked out for a second there. So intersection, when you use the word and in the Venn diagrams, we usually want to talk about the intersection. So now, if we want to know those students who take Spanish and also take an art, so basically what we need to shade is the intersection of the circles that talk about for Spanish and the circle that talks about art. So that's pretty much, this is the only region where the two circles intersect. So this is the shaded region that we're interested on. So now, if we look at example D here, and let's do that in blue. Let's do that in orange. Here we want to know those students who take Spanish or take an art class. So we know that when they use and, we want to figure out the intersection. Here, when we use the word or, this is kind of like the opposite. When we use the word or, it's not the intersection. Intersection. Good. So and we can think about it as the intersection between the groups. And or is not the intersection because it's either Spanish or art. It cannot be both of them. You need to choose one. So now, how can we shade the region that talks about Spanish or art? Well, we're gonna shade the circles. This is the circle for Spanish, but again, because we're using the word or, we're not going to take in consideration the intersection, and the same goes for art. Here's the art circle. And now, what are we going to be shading? This region. This is the intersection for those who take Spanish, and here's the intersection of those who take an art. Notice that we did not circle anything in the intersection, and that is because we're using the word or. Either you take Spanish or arts. You cannot take both of them. So that's why we leave the middle as an empty space. So now let's look at the last example here. For example E, we're interested, let's do this in purple. Now we're interested in those students who take Spanish but do not take an art class subject. So notice that here we do not want to shade anything that has to do with the art circle, but we do want to circle, or we want to shade the section that still talks about Spanish. So what is that section? That section will be this portion of the circle. This is a section for those students who take Spanish and do not take an art class. Because notice that this, and I mean, if you want to be picky, we should not be putting anything on the art circle. I guess that's better. Here, we do not want to take anything that talks about art. Notice that even if we shade this small region, this little point is still part of the big circle which talks about art. But we do not want to take in consideration anyone who takes an art subject, so we definitely don't want to include anything that has to do with the circle of arts. So this is the correct region of those students who want to take Spanish but are not going to take an art subject. Now, when we talk about Venn diagrams, it's not just circling and shading. Sometimes there will be numbers involved. So here's a clear example of what we're about to talk about. Here, again, when we talk about Venn diagrams, get familiar with the scenario. So what we're going to do here is let's understand the scenario. So here, we're talking about when a player is selected at random from a high school boys baseball team, the probability for that pitcher that he's a pitcher is 0.35. So we're in a high school, and there's a probability of 0.35 that a student will be a pitcher. Now, the probability, okay, so pitcher is 35, 0.35. Now, the probability that he is a right-handed, so the probability for being right-handed is 0.79. And now, the probability that he is right-handed pitcher is 0.26. So this is kind of like the main information that we want to be concerned about. So we're going to talk about high schools. We know the probability for someone to be a pitcher is to be 35. And we know the probability for that person to be right-handed is 0.79. And we know that the probability for the person to be a pitcher right-handed is 0.26. Now here, what do we know? We know that P stands for pitcher and R stands for to be a right-handed. Now, a Venn diagram is provided below. Okay, excellent. Now, let's use the Venn diagram to calculate the probability that a randomly selected player is each of the following. And we want to explain how we're going to use the Venn diagram. Okay, so here we want to know the probability of what is it for a person to be a right-handed but not a pitcher. So let's see, the first thing I want to do is actually put those numbers in the Venn diagram. Let's put them in this correct color. So pitcher, it's 0.35. So we know that this big circle is going to hold a value of 0.35 because that's what it says here. This whole circle is for pitcher. Not a great job with the circle, but you get the idea there. This whole circle is for pitcher, and this whole circle is going to hold a value of 0.35. Now what else? For it to be a right-handed is 0.79, so we know that the value for the circle to be right-handed is 0.79. So this whole circle is going to hold a value of 0.79. And for that person to be a right-handed pitcher, which is, we know that this circle is for pitcher, we know that this circle is for right-handed, so that means that the intersection here is the right-handed pitcher, which we know is 0.26. So let's see. Now, in A, we want to know what is the probability for it to be a right-handed but not pitcher. So let's figure out which circle are we talking about. So right-handed but not pitcher. So in theory, we are concerned about this section because this is the section where it's right-handed but not pitcher. But how can we figure it out the probability for just this region? Now, this is not 0.79 because 0.79 is the whole circle. So if you want to know just this small section, that will be the whole circle minus this little section gives us the section that we want. Notice that here, this is the whole circle for right pitcher. If we take out this section here, we're just gonna have the section that we're interested on, which is right-handed but not pitcher. So what is the probability? Well, we know the whole circle is 0.79, so it's 0.79, and let's do that in a different color. So we know that the whole circle is 0.79. If we take out the little section in the middle, which is 0.26, we're going to have this intersection that we just demonstrated previously, and this is a total of 0.53. Now, 0.53, that's kind of like what we wanted because this is exactly this section, which is basically the whole circle minus the intersection gives you this. And if we shade this region, this is 0.53. But let's erase that because it might be a little bit confusing. All right, so now let's look at the other example here. We want to know what is the probability for someone to be a pitcher but not right-handed, which is the opposite scenario. Now, let's identify the region that we're interested on. We're interested on the region that is pitcher but not right-handed, which is this section. This is the section that we're interested on because this is pitcher but not right-handed. Now, how can we figure out this whole region? Well, again, it's the same idea. It's basically the whole circle minus the intersection. We know that at least for pitcher, the whole circle is 0.35. So that would be 0.35 minus 0.26, which has a total of 0.09. So that means that the value for this region, the shaded region here, is just 0.09. And this is exactly the region that we were interested on, which is the whole circle minus the intersection, which is a picture but not right-handed. So now, here's your entrance ticket. Understand the following scenario and shade the correct region.